Welcome to qnawire.
For this problem, on the topic of sources of magnetic fields, we are told that a model airplane with a charge and a given velocity passes through a wire nearly parallel to the path of the wire. Now the current of the wire is given, and we want to calculate the acceleration this interaction will give the airplane. So the magnetic field from the wire at the location of the plane is perpendicular to the plane's velocity. Since the plane is flying parallel to the wire, we can calculate the force on the plane and hence the acceleration. Now, we know that due to the magnetic field, the force on the plane, F, is equal to the charge Q times its velocity V times the magnetic field strength B. And we can write this as QV, and we can write the magnetic field strength due to the wire as mu naught I, where mu naught is a constant and I is the current carried by the wire, over 2 pi r. Now we are given the distance between the plane and the wire, so that will be r. Now if we find the acceleration, we know that by Newton's second law, the acceleration A is equal to the net force which is acting on the plane divided by its mass. So we can write this as Q times V over m over mu naught times I over 2 pi r. And now all these values are known, so we can calculate this acceleration that the plane experiences during this interaction. So the charge on the plane we know is 18 times 10 to the minus 3 coulombs. Its velocity is 2.8 meters per second. We know mu naught is a constant, and in SI units, this is 4 pi times 10 to the minus 7 Tesla meter per ampere times the current through the wire of 25 amperes. And all of this divided by, firstly, the mass of the model airplane, which is 0.175 kg, times 2 pi times the distance that the plane flies to the wire of 0.086, and that's in meters. So now if we calculate the acceleration that the plane really receives during this interaction, we get 1.67 times 10 to the minus 5 meters per square second. But we want to calculate this with respect to gravity. So this becomes 1.7 times 10 to the minus 6 times g, which is the acceleration due to gravity.